So today I'm going to be talking about some of the technical aspects of the CPIC database and API. But first, I want to thank all the people that are beta testing. Any feedback you give is very useful, and I really appreciate it. I'm going to review some parts of the system, and then after that, we can take some questions. We can discuss anything that you have thoughts on, or if you need any clarification on stuff. So where do we start? You can start learning about the CPIC DB and API from the cpicpgx.org website. So right now, there's a API and database page over there. It's a little sparse at the moment because we're just in beta testing. But once this goes live, we'll have more information here to get to all the technical documentation and everything you need to know to get started. Eventually, it will be a link to this GitHub wiki page, which all of the beta testers should have access to, and eventually all the public will have access to once we go version 1.0. Using the API. So on that wiki page, there is a section on there called Using the API. The API, just to review, is mostly meant for people that want subsets of data, information about like particular genes or particular drugs, or like, you just want something like you only want frequencies and you only want it limited to a certain type for like a particular gene or something like that. Currently, the API has no limit on the requests that you can issue. However, if the system gets overwhelmed or the performance starts to suffer, we might start to introduce some API keys or some other rate limiting rules. So hopefully people will be nice and treat it well. The API is dynamically generated from a system called Postgres. It automatically creates a REST API based on the current structure of the database. Basically, it goes in and looks at all the tables that exist and then all the properties of those tables, and then just automatically generates API based on that. This ensures that the data model and all the property definitions in the database match what's available on the API, so we never get out of sync between the two. Now, Postgres does have a particular syntax for issuing requests. It might be a little bit different than what you're used to if you've used other REST APIs. The structure is the same in that you're using query parameters to limit your responses, but it has a pretty well developed set of operators and filters that allows you to do a lot of stuff that would take a lot of custom code for me to write. A lot of that's just brought in with the Postgres system. So it might seem a little odd at first, but it makes the system a lot more flexible for you to get whatever you need out of the system. Let's take a look. In that wiki, under the Using the API section, there's a link to this Postgres, or this Postman system. I created a bunch of example API requests and put them all into this system called Postman, which is an API development app. For example, this is a function reference endpoint that you can use to look up information about the allele functional reference information. Here you can see that it's using the allele data model. Because this is the prefix for the API. There's the domain, and version 1 is the major version of the API. Below that, there's a short explanation of what this request is for, and below that is a list of all the parameters used in this request. You can see we're limiting this to the CYP2C19 gene symbol and the allele name of star 17. And then notice how we have to prefix these things with the EQ to say we're looking for equality, name equals star 17. Also, notice that we're using the select parameter here to select only certain fields that we're interested in. So you can see over here in the example output, it's limiting to just the fields that are listed here in this select query parameter. If you don't specify the select parameter, that's okay. It'll just return everything. In fact, why don't I switch over? Here's a desktop version of the Postman tool. It's the same exact thing. In fact, it publishes from here to that website. But here you can actually see me run the API request. So I'm sending I get back this request. If I take off the select parameter, you can see now I'm getting a whole bunch more properties that are included in the response. So this is a way of, if you don't want the entire payload to be returned to you, it's a way of slimming down your response and getting just what you need. All of these examples that are over here in this system are handwritten by me. So I'm writing these query parameters and stuff like that. And I try to include these descriptions in the API requests. So if you want to see particular examples, or if something's not clear, just let me know and I can add more requests to this, or I can change up some of the parameters here and make it a little clearer. Let's go back over here. Okay, so those were the example, the particular hand-picked examples for the data model. If you'd like to see all of the data models, all of the documentation for the entire API, there is a document, an open API document that's generated automatically from the Postgres system. It's generated from the same system, so it should always be in sync with what's current in the database. You can run, I'll open this up here real quick so you can see, you can see the list of all the different data models that are available. It's an exhaustive list. And you can even open up some of these sections, like here, if I want to pull up allele, I'll open that guy up. And this gives you a description of all of the specific properties for that particular data model. So you can see here, like clinical functional status, the gene that this allele is for, the name of the allele. And we've got these descriptions here. These descriptions are all synced between the systems too. So if you scroll all the way down, you'll see that it gives you some example request responses and stuff like that. And I think up here, there's a button here that says try it out. So that will turn all these properties into fields, and you can fill in particular things. Like here, if I say, let's try this, equals SIP2 to C19. And then if I go all the way down, I know there's a lot of properties, go all the way down, hit execute, and here's the response. So you can see this is going to give you all of the different alleles for SIP2C19. You can see here's gene symbol SIP2C19, here's *1, here's *5. It gives you all the different properties that are available for it. So this is a great place to go if you want to see everything that's available. It's very technical, and there's a lot of stuff going on in here. So it might not be the best place to go to first, but it's definitely an exhaustive list if you really need to see a specific example. Let's see. So now that we've talked about the API, I'm going to talk about the database itself. And in the wiki documents, there is a section up here called using the database exports. The database is a Postgres 12 instance, and it is the source of truth for all the other forms of this data. I think Postgres is a fantastic database. It has server software available for all the different major operating systems. It can run in the cloud, in AWS, and all this other stuff. So I think it's a pretty good fit for most people. The API, as I said before, is generated from the database. So eventually, gene-specific Excel reports linked from the CPIC site will also be generated from the database too. You can read this documentation here about the database. It doesn't go into a whole lot of specific detail about Postgres itself. I leave that to the Postgres docs. But the stuff that you need for consuming the CPIC database should be listed here. We're exporting copies of the whole CPIC database for you to use. These copies are available in the GitHub repo as releases. So if I click on this, it'll take you to the release page of this CPIC data repo. And you'll see all the previous releases that have happened for the system. Each release is assigned a version number, and it includes release notes about any important changes or other bug fixes and whatnot. For example, I recently changed the name of a few tables in the DB, so it's noted in this release. It used to be called gene phenotype, but I've since changed the name to gene results. So you'll see a gene results API endpoint, and you'll see that also reflected in the Open API docs. If you open up the assets section here, this is where you'll see a file that should be started with CPIC DB dump, and then it'll show the version number for it, and that should correspond with the version number up here. That is a file that you can download and import into your own local Postgres instance. You probably don't need to care about these source code links. You know, they're there if you want them. That's just the code that GitHub automatically packages with every release. But this is probably the one that most people are going to want to use. These releases, if you click the watch button up here in the top right, this watch, that will get you notified whenever whenever we release a new version of the database. So as soon as I release one of these guys, if you're watching it, you'll get a notification through the GitHub system to let you know that something's been released. Database changes. So if you're interested in the actual structural changes of the database, you can check out the Flyway migration scripts. So if I click on this, this is part of the CPIC data code base. These are scripts that are used to add like columns, change tables, do other stuff in the DB, like that change that you just saw of me changing the table name. That's one of these scripts that's in here. Each change is part of a Git commit. So you'll see these are the different change files. Each one of these is associated with a Git commit that also gives further information about all the other sort of contextual changes that happened because of this. For example, if I look down here at this V27 file, this is me adding, you can see I've altered the allele definition table. I've added a reference column, and you know, I've made this comment here. This is just a little flag, a Boolean field that just says for each gene, flag which allele is considered sort of the reference allele, you know, which all the other alleles are compared against when, you know, showing in sort of the grid UI and stuff like that. So this is used for a few different things, but this is the code that actually goes in and modifies the database and sets the values. Here is a quick ER diagram that I generated from one of my database tools of some of the tables that are in the database. You can see each table, or each rectangle is a table, and there's the properties that are listed inside of each table. Each one of these lines is a relation between the tables, a foreign key relationship. So there's a column in here, for example, like this gene result table links off to the gene table via this gene symbol property here, matching the symbol property up here, which is the primary key. In addition to these tables, there are some other helper views that aren't listed here. Those are defined with some joins already put together, like a couple of these tables will be put together and maybe some of the columns are filtered or pre-combined in order to make it easier for you to digest. For example, I think the pair table, the gene drug pair, there's a pair view model that allows you to see the drug name easily, and a lot of the values reflect what's actually being shown on the genes drugs page on the CPIC website itself. But to zoom back out to the sort of the higher abstraction layer, we also in the GitHub wiki document the data models. And we have, if I click on here in the GitHub wiki, there's this data model section. And this documents sort of the high level explanation of what these data models are meant to represent and why the tables are organized the way they are and the things you need to know to properly understand the data. For example, let's look at the allele section here explains why we have separate allele and allele definition tables, which can be a little mysterious if you're just looking at the database and not looking at the documentation at all. There's only so much documentation I can stick into the database itself. the rest of it goes in here. So that way you can understand sort of why it's organized the way it is. So if you're a little confused about sort of what tables are or why they exist and how they relate to each other, come back up here to this data model section in the GitHub wiki, and this should help describe to you what it's about. This section includes some example API requests. So you can see these down here. This is very similar to what was in the Postman system. However, it also includes the actual SQL query that should be analogous to this API request. So if you're running a local instance of the DB, here's a query that you can use to get the same deal. But if you're just using the API, that's the API example that you can use. Okay, so that was a good amount of information. If you see any problems or need clarification in the system, please, I'm relying on people to use the GitHub issues system. So in the repo itself, there's this issues tab up here. You can always submit a new issue if you run into an error, or if something's unclear, you just need some questions, feel free to file an issue and I will go through and try to address it.